Well, good morning, everyone, and thank you for coming. My name is Kevin Hogan, and I'm here today representing Focus on Energy's New Homes program, formerly known as the Wisconsin Energy Star Homes program. Focus on Energy broke away from the federal program about a year ago in an effort to have a more homegrown program that was designed for our northern climate, and also designed more for the type of builder that we have here in Wisconsin, meaning a custom builder. The federal program has leaned towards production builders, people that are building 5, 10, 20,000 homes a year. And the requirements became much more elaborate than our state version, and we worked together with builders throughout the state by having roundtable meetings, and we found out that from the builders themselves, they preferred to have a program very similar to what we had, and their advice was to break away from the federal program, and so we did. And that's why it's called the New Homes program rather than the Wisconsin Energy Star Homes program. One of the reasons that we were asked to have a presentation here is to tie this together with renewable energy. As I'm sure most of us sitting in the room know, it's really important to get the load down in your home before you start to add a renewable energy source. Otherwise, you're putting on solar arrays that are extravagant, very expensive, and perhaps not needed. So the idea is to build the shell of the building very energy efficient, make it very airtight, provide mechanical ventilation, and advise the homeowner as to how to actually operate that home. So those are some of the things that we'll be discussing. And I'd like to say that if you have a question, I'd rather try to address it right away than try to wait till the end. It has more impact and more meaningful, and it may raise another question for somebody else. Basically, we're going to be talking about three areas. One, I want to briefly introduce what Focus on Energy is, describe in some detail what the New Homes program is. I do have several handouts up here if anybody is interested. I'll leave those on the table. And then the last thing is, well, answer questions, but really I'd rather do that as we go along. So basically, well, what is Focus on Energy? It's our statewide program that promotes energy efficiency and renewable energy. It is throughout the state. And by the way, Focus on Energy is only for the state of Wisconsin. No other state has that. They may have their own programs, but Focus on Energy is strictly the state of Wisconsin. It's actually state legislated back in the year 2001. So it's actually a law. Everybody sitting in the room probably is paying into the Focus on Energy fund. If you were to look at your utility bill, whether it's gas or electric, you probably find a line item on there, maybe entitled Public Benefits or some other verbiage to that effect. But what that is 1.2% of your utility bill is being collected to fund Focus on Energy. And that money is earmarked for energy efficiency programs throughout the state. So we're collecting in the neighborhood of about $95 million here in the state of Wisconsin. So the lower your utility bill, the less contribution that you're making.
Are you in jeopardy now?
Are we in jeopardy? No.
With the new...
No, Focus on Energy is fully funded, and so she asked if Focus on Energy is in jeopardy right now. And
with the new governor?
Oh, no. But what did happen was a couple of years ago there was a proposal to increase the amount of funding every single year until they reached a max of around $255 million. That was shot down, so we stayed at current funding. But we're still collecting, like I say, around $95 million a year to help promote these programs.
Thank you.
Okay, thanks for asking that. So this is this partnership of investor-owned utilities as well as municipally owned utilities, and about half of the electric cooperatives throughout the state. We probably have about 95% coverage. Where it gets a little bit scattered is up in the northwest part of the state, and there are some areas where people are using either LP or fuel oil, and then they might have a electric cooperative that's not part of Focus on Energy. There's a few of those scattered around the states. But for the most part, we have pretty much full coverage. The idea of this is to have one energy efficiency and renewable energy program that covers the whole state rather than utilities operating their own separate programs. because it gets a little dicey when you have that. For example, back in the late 70s and early 80s, investor-owned utilities were mandated by the Public Service Commission to do residential energy audits. That program was called RCS, I think Residential Conservation Services. And what that was to help people that had existing homes figure out what they could do to reduce their energy bills. It was mandated. So you had a utility person going in trying to promote energy efficiency. It was kind of like unselling the same product they're trying to sell. And it was a little bit tough to make that argument. Whereas this model, we have independent people that are doing this, that are promoting the program. They have their own equipment. They are well educated, but they're depending upon themselves to provide the service. And it's much more accepted by the public as a result of that unique relationship that we have. And Wisconsin is one of the only states that has used that independent type consultant. What Focus on Energy does is try to help Wisconsin residents and business implement these energy-saving projects. The idea is to try to offer, as much as possible, unbiased information, technical assistance. Most of the people that work in these programs are very well versed in what they're doing. Oftentimes they'll come to the industry from the trades. For example, I used to be an energy auditor for one of the utility companies back in the early 80s. And so I probably did 1,000 energy audits, and that became the base for my background. I also worked for an insulation company years ago. And so I had some real hands-on, in-the-trenches type work. And when I came to work with Focus on Energy back in 2001, it wasn't that I was green off the street and like a fresh turnip. I had a background, and that adds credibility to what we're doing. The idea is that we want to also offer some cash incentive, because we know sometimes people are on the fence as to what to do, and sometimes the energy savings alone aren't enough to encourage people to take on these projects. The thing I've learned about energy savings and rate of return is that, for example, if somebody says, well, that's a 5-year payback, that's too long, I can't wait 5 years for that payback. Well, if you think about the numbers, what a 5-year payback is actually a 20% return on your investment. And who wouldn't put their money in to get a 20% return on investment? The other nice thing about energy savings is that it's money in your pocket that never gets taxed. And as utility rates rise, the amount of money that you're saving, it increases. So there's just lots of good reasons to save energy. That's just the money side of it. Then we get into the comfort and the durability issues, and that's part of what this new homes program is all about. And I'll get into that in just a moment. So the cash incentives help people that are on the fence. It also helps plan projects to be completed a little bit sooner than expected. This is where the money part comes in. Since Focus on Energy started back in 2001, the rate of return was $2.30 for each dollar invested. That's a fantastic rate of return on money. A lot of state programs throughout the country don't come anywhere near that. I think part of the reason why we do so well in Wisconsin is because a lot of the people are very well educated and have been for a number of years. While those energy audit programs from the utility companies may seem like why would you have a utility person try to save energy? The one good thing that they did was it helped to educate people. Now you've got somebody inside that home that has the opportunity to work with a homeowner and help them figure out what's going on and help to educate the homeowner right on their home turf. And that's a big advantage. Back in 2010, a little over $16 million was paid out in residential incentives. Now on top of that, there are other business incentives as well. We've had about 1.7 million participants since the year 2001. And we are dealing with about 10,000 trade allies over that course of time. Trade allies might mean independent consultants, it might be builders, it might be remodelers, it might be somebody who owns an electric retail store, insulation companies, roofing companies. The whole wide range of anybody who works on a house is included in that 10,000 trade allies. Some of the customers that we serve through Focus on Energy are single and multifamily homes. commercial, industrial, agricultural. We get involved in institutional buildings like hospitals and universities and other schools, government facilities, and even communities. We have community projects going on. So now we get into the New Homes program, and how this all got started was a brainchild from somebody from the state of Wisconsin that said, you know, we know an awful lot about existing homes and how they work and how to fix them, but how do we build out potential problems like ice dams, condensation problems, indoor air quality? How do we build that out so that we don't have those problems to begin with? And that's where the New Homes program got its start, was that there was value in that. The utility programs, the utilities had a program back in the mid to late 80s that ran up until around 1993. And some of you may remember this. It was called Good Sense. Now, that was a builder program where the utility person would model the house in a computer, and they would go out and make checks on the house as it was being built, and at the end they would go through a prescriptive list to make sure that it met all the requirements of the program. But they missed one very, very important component in all that, and that is performance testing. And that's something that takes place in our New Homes program. Lower energy bills, of course, are on everybody's mind because the general direction of energy bills is going to be more than likely in this direction. Now, I understand that we have a glut of natural gas right now, and so we're seeing depressed prices, and that may stay for a while. Nobody really knows. It looks like electric rates are probably going to continue to rise, though, as we go on. And so there's another reason why we want to have a program like this to help people right from the get-go, because I've heard many times that people say, oh, I wish we would have done this when we built the house. For example, I wish we would have put some foam insulation under the slab, or I wish we would have added more insulation to the foundation before they backfilled, or I wish we would have put in better windows or a more energy efficient furnace. Woulda, coulda, shoulda. You know, it's all kind of past tense. The idea is that if we can get there right in the beginning and help with builders and general contractors and homeowners while the building plans are in their hand before they've ever put the shovel to the dirt, we have a much better chance at convincing these people this is a great way to go. We feel that homes that have been through this process and have been certified, and by the way, we've certified over 17,000 homes since the program got started. And the market share right now is about 25% of all building permits. Those homes are being certified homes. So we're finding value. So that's not bad, considering the program's only been around for about 10 or 11 years, to go from zero market penetration to about 25, 26, 27%. And those numbers continue to increase because we find value in this. So we feel as though those homes that have been certified have a better potential for higher resale value, or at least greater saleability of the home if you can demonstrate what those energy bills are. Proof positive, what we mean by that is the fact that we actually performance test homes after they've been completed. And a couple of slides from now, I'll get into a little bit further detail about that. So here's the process. We have the certification is what we're aiming for. And the certification is based upon standards or requirements that have to be met. I won't go into great detail as to what they are, but I will touch on them because they deal with certain things that have to do with insulation levels, combustion safety situations like furnaces and water heaters. We're trying to make sure that we're building very tight homes, but that we're also building homes that have the potential to have good indoor air quality and not have the junk of the combustion products spilling back into the home. So that's the goal, is certification. And it starts with the building performance consultants. These are people that have come to us from the trades. They might have been builders themselves, they might have been remodelers, they might have been energy auditors like I have been, but whatever, these building consultants come to us from the trades. They went through a very rigorous training session, and then they're individually mentored for upwards of 4, 5, 6 months if necessary, until we deem them to be roadworthy to go out there on their own and provide this service. Now, there's a charge for the service, and the consultant will charge anywhere from $500 to $900 for the service, and that will depend upon the complexity of the home, how far the consultant has to travel, how many visits that they make, how much hand-holding is going on, that sort of thing. So there's no one price fits all. The next step is the computer modeling, and this is where the program really shines, because we sit down with the building plans before the project even gets started. And we can model the house into the computer program to tell us what the energy bills will be when we're all done, and what percentage over and above Wisconsin Uniform Dwelling Code is this house compared to energy efficiency. And that's a big thing. Yes, sir.
What program do you use for modeling?
The question was, what program do we use? It's called REMrate. And REMrate is, there's only 2 programs in the state of Wisconsin where builders can pull permits to build a house. One is REMrate, and the other one is ResCheck. ResCheck is a kind of a general type program to figure out, what the energy bills will be, but to pass certain criteria in order to pull that permit. REMrate gets a lot more sophisticated. What we're trying to do is to model this house into a computer that will tell us what's the square footage of the slab floor and what is the R value, if any, under that slab floor. What is the insulation value on the foundations, walls above and below grade? What is the insulation value in the above grade walls? What's the performance numbers on the windows? Solar heat gain numbers as well as conductance. What direction do the windows face? What's the shading aspect on those windows, winter and summer? What's the insulation value in the rest of the areas of the house, ceilings and knee walls? What's the efficiency of the heating system, the cooling system, the water heater? Does it have a ground source heat pump, air source heat pump? What kind of system is involved there? Once we know all of those things, yes, sir?
Is this a website that we can go to and model a home that we're considering building?
No, you have to buy into this, and not it. I don't even know that if a private citizen could actually buy into that, because there's training involved in it. So you'd have to work with a consultant, and there's a list of consultants on the Focus on Energy website.
If you're Illinois?
Nothing in Illinois that I'm aware of like this. There is the federal program in Illinois. There is that. Pardon? Well, there's REMrate in Illinois, but I don't know that they have a building program for new construction in Illinois. I'm not sure.
Well, actually, now we do have, I was supposed to audit homes using the code. Instead of doing a prescriptive type of energy audit or energy efficiency value, you have to test on new construction using
Okay, well that's the goal. We're trying to help raise the bar throughout the whole country by having a program like this. Yes?
I believe ResCheck is available online, but
ResCheck is, yes.
you really need to know how to use it.
Right. Building supply outfits will have that. Heating contractors know how to use ResCheck. But REMrate is a lot more sophisticated. The beauty of REMrate is that we can accurately predict what the energy bills will be. We can't predict what the lifestyle will be. We can't force homeowners to keep temperatures low in the winter and high in the summer, but we'll put in set point temperatures in that program, and we get very, very close. So that helps the homeowner figure out how much money do they have for disposable income to buy those granite countertops and the lavish carpeting and all of the other eye candy that we see. If you know what the energy bills are, that helps you plan a budget. Somebody had a yes.
Do the homes receive a HERS score after you do all that modeling?
We no longer use a HERS score, because the HERS score is actually modeled under some nebulous home somewhere in cyberspace. What we're now comparing it to is Wisconsin UDC. We want to know how much more efficient is the house that we're modeling, how much more efficient is it versus the regular UDC. And we have actual builder rewards that are based upon the difference in energy efficiency. Yes?
So if you have a Energy Star certified builder and you build your home to that standard, would this kind of all be encompassed within that, or is that?
The only way that the house would get certified is if you have a consultant that's associated with Focus on Energy on board at the beginning of the project. And we'll see when we get to site visits why that's important. But I wanted to get through. The question was, I believe, can anybody have a certified home even if they don't use a consultant as long as they get the house modeled? And the answer is no. They have to work through a certified consultant, and that's part of this program. Okay, so that the computer modeling really is the key. And as when the project gets finished, we go back and we modify the computer model because maybe during the construction process people have changed their mind about window sizes, window direction, window performance, efficiencies of heating systems. Who knows? Things can change. Yes.
The computer modeling, is that done by the building performance consultant, or is there a computer modeler that
Nope.
does the computer modeling?
Okay, that's a very good. The question was, who does the modeling? Does the consultant do the modeling or some computer whiz that does the modeling? No, the consultant does the modeling. And that's the training that they start off with. It's a 2-week, very intensive training, and then they get mentored for a period of time to make sure that they understand how that program actually works.
May I ask how much is the 2-week training program?
Well, currently they don't have a program scheduled. But in the past, it's been around $1,500 to take that training.
And then the mentoring is additional charges?
No, he asked the cost to become a consultant at the time that they were certifying consultants was around $1,500. We haven't done any certification the last year or so, and I don't know what Focus on Energy has planned for the future. And your second question was, do they charge for the individual mentoring after they go through the course? And there is no charge for that. That's all part of the package. So the other area that we get into is the site visits. And this is critical. Where we have a mandatory 2 site visits. The first one is after framing, and typically after the wall insulation is installed, but prior to drywall. What we want to do is inspect the framing, looking for potential unintentional air leaks so that we can take care of that right from the get-go while the house is still in that skeletal state. The other thing is we want to make sure that the insulation in the wall cavities meets. Nice catch. And so the insulation actually gets graded on 1, 2, or 3 basis. And what we're doing there is we're trying to raise the bar on installing performance from the insulation contractors. Rarely does the builder install their own insulation, so they're relying upon an insulation company. But the idea is to have a third party coming in and actually critiquing that installation and then helping that insulation company become better and better at what they do. We advocate premium insulation systems like what's known as a BIBS. That's a blown-in blanket system where they would put a fabric over the studs on all the exterior walls, and then they'll fill that cavity after that membrane is installed. They'll fill the cavity with a blown fiberglass. Another product that they'll use is cellulose in the same situation. Or perhaps they'll use what's known as a damp spray cellulose, and it's water and adhesive mixed in. And the beauty of those products is that it fills in behind electrical outlets and piping and wiring. It's very difficult to expect an insulation company to install fiberglass bats perfectly around all of those obstacles, so to speak. Where the blown-in, well, that's a snap. And you pay a little bit more for it, but you get much better performance. But either way, we don't have a requirement as to what insulation product that you use. We remain unbiased in that regard, but we try to promote the use of a better insulation system. Because the money that you save doesn't just get saved the first year. The beauty of insulation is that it continues to work year after year after year. And then there's also the comfort issues and the quietness issues and all of that comes into play. So the site visit yes?
How do you deal with the sys panel
Well, that's a whole different ballgame. We're not gate. We already know what the value of that is. He asked about SIPs, which is structurally insulated panels. Usually, it's a white expanded polystyrene sandwiched between two pieces of OSB or plywood, and the thickness can vary. But it's a great way to go because the wall is super tight, provided that all of the junctures where the wall and the ceiling meet, where interior walls meet exterior walls, where the exterior wall sits on top of the rim joist, all of those areas need to have attention paid to that detail. And we'll end up finding out just how well they did with a blower door test later on. So that initial site visit during the framing stage also allows us to see what kind of framing techniques that they're using. Is there a way to reduce the lumber without sacrificing the integrity or structural integrity of the home? And there's a good chance that there is. Now, our consultants aren't structural engineers, but we have a good idea as to what's practical to use. And oftentimes we'll be able to advise builders to spend money on corners, for example. If you think about the way a corner is built, and in the wintertime in our climate we have this thing called expansion and contraction. You probably have heard about that. Well, where you'll have movement on those corners, and there's a lot of energy loss there. Typically, when we do an infrared scan of a house that's been built, when we have a blower door running and we're depressurizing the house, we find corners to be notoriously leaky for a variety of reasons. The cavities are small. Oftentimes they are haphazardly insulated. The fact that when wind blows on a building, it will blow down along the side or the plane of the building until it reaches the corner, and then it starts kind of a turbulence, a rotating effect, and that pulls heat away at even a greater rate. So corners are tough. You know, years ago when we built houses with only 4 corners, that was one thing. But now we build houses with 20, 30, 40 corners, insets, all kinds of architectural detail that is very pleasing to the eye, but it plays havoc with your energy bills and comfort as well. So again, we see this with infrared cameras. It's glaring that corners are notorious. So we would advocate that you consider spray foaming those corners, at least spray foaming the vertical seam, if not the entire small cavity. That's a great way that we can help improve the comfort of the home. We advocate spray foaming the rim joist area. That's the area right above the foundation wall. If it's a 2-story house, there'll be a thing called a band joist. We advocate that you spray foam the band joist as well. Tremendous heat loss areas in those band joists and rim joist areas. So the idea is that the consultant is not just there writing down numbers and doing a prescriptive checklist. He's there in a real professional capacity. He or she, we have lady consultants as well, but they're there in a professional capacity to help that builder so that as they build more and more homes, they become better and better at doing all of this. Yes, sir.
I never heard of that spray foam. Is that like great stuff?
Two-part spray foam is usually what they'll use. It's a urethane foam. And you can buy them in kits, like a 200 or 600 board foot kit. A board foot is 1 square foot, about 1 inch thick. But a lot of times the insulation company will have a rig where they have 55-gallon drums of the two materials, and they're heated, and they'll have like a 300-foot hose, and that hose is heated as well. So when the foam comes out the end of the gun, it's coming out at the precise right temperature to get good yield.
What about just like 2-inch formula around?
Well, that's fine too.
Yeah, it seems like it's simpler.
Yeah, it's just the spray foam is very, very fast. That's the thing. It's just whoosh, you're done. You move on to the next one. What he's talking about stack construction is where you line up the floor joists with the wall studs and then the ceiling joist going overhead. Everything lines right up. And when they do that, you can then spread out the wall spacing from 16-inch on center to 24-inch on center and still have the integrity. That provides more space for more insulation. And that's a great way to go. Choosing the right builder. Any builder can say, oh yeah, I build energy efficient homes. Oh yeah, I've been doing that for 40 years. Don't worry about that. You don't need to have one of these fancy consultants come in with their There are blower doors and infrared cameras. We already know how to do all of that. We've been doing this for years. Well, it's easy to say that, but the proof is in the pudding. Meaning, will it hold up to performance testing? So I would say to that builder, well, okay, have you taken into consideration air tightness? And how do you measure the air tightness? And that builder may say, well, you know, we don't want to build them too tight. We want that house to breathe a little bit. You know, that's important. To that I would say, well, okay, then please describe to me, how would you build a house to be, how would you build it loose enough so that on a windy day it's not overventilated and on a calm day it's not underventilated? How do you do that? Well, that's a good question. It's kind of what it comes down to. The idea is that we do advocate for very tight construction, but we follow that up with mechanical ventilation. So build tight, ventilate right. And by mechanical ventilation, we're talking about quiet equipment, not necessarily elaborate or expensive, but quiet equipment is very important. User-friendly controls. A real simple way is to put in a good quality bath fan, whether it's in the bathroom or in the hallway of a house, and wiring it to a switch called a dehumidistat. That's the same kind of switch that is used on dehumidifiers. The idea is that I got some competition. The idea is that you would set the humidity level during the 3 heating seasons, or like fall, winter, and spring. And let's say you set the humidity at 35%. The sensor in that switch will turn the fan on if the humidity rises to that level. And then as you move that amount of air out of the house with that mechanical fan, an equal amount of air is being pulled into the house, because we can't build them completely airtight. We use the term airtight, but it's kind of a misnomer. You can't completely make it airtight. And even if you did, then what you would do is you would strategically place some passive vents in to allow that air to come in. But the idea is that every cubic foot of air that's forced out, another one comes in. In the wintertime, that air is very dry, and it will tend to drive the humidity down in the house. And you might say, well, boy, I'm going to pay for all that heated air that you're going to be exhausting out of the house, and I'm pulling in all that unheated air. That's going to cost me a lot of money. Typically, the cost of that fan is well under $100. In fact, in most cases, the cost of reheating the air also falls into that under that $100 or thereabouts. So we're talking about fairly good indoor air quality for less than $100. There are other mechanical ventilation systems that you can install. For example, air-to-air heat exchangers. And they'll come in a variety of different styles. Heat recovery ventilators and energy recovery ventilators. And I'm sure that if you went through the fair, you're going to find people that sell that kind of equipment. You can get more detailed information. But the idea is that you have an equal amount of air coming in as opposed to going out. And the air passes through a core that transfers the heat energy. And the core material may also allow some water vapor to pass through it. So that's the difference between the heat recovery and the energy recovery. But you're not just losing all that air. The recovery efficiency is around 70 to 75%. And it's a great way to provide continuous fresh air to a home. And then you would also do spot ventilation in kitchens as well as in bathrooms. Try to get rid of the moisture and odors right at the source before they're allowed to spread out into the rest of the house. Here's our contact information. There is a booth. Focus Energy has a booth down behind that big exhibit building on the east side and on the south end. There's a booth down there. The question was, what's the cost difference between constructing a house like this that meets the criteria and one that's not? Well, that is all over the board depending upon how elaborate you want to get with that. But typically, we might be looking at very little cost, maybe $500 more or perhaps $5,000 more, depending upon what measures that you're putting in. I talked to a builder friend in Appleton who has been extremely successful at selling energy efficiency. And what he found out was, after installing a ground source heat pump, PV panels, as well as solar water heating, He said if I had to do this all over again, I would not put in the ground source heat pump. I would put more of that money into the shell of the building. Now, we talked about the energy savings, but there's a huge difference in comfort when you're adding, say, 2 or 3 or even 4 inches of foam to the exterior walls of a home. In Europe, they're going with 8 to 12 inches of foam on the outside. The reason being is energy prices in Europe are astronomical as compared to what we pay here. So the driving force hasn't reached us here in America as yet. Yes?
What about air-to-air heat pumps? There's a lot of them that are more efficient.
Air source heat pumps?
Right.
Oh yeah, it's like furnaces. There's a variety of different efficiencies of those.
Have they been well used in climates like ours?
Absolutely. Yeah, they're very practical. Maybe in the case where you've got radiant heat instead of a forced air furnace, ductless air source heat pumps work really well. I live in Sheboygan Falls, down near Sheboygan, and we're about, 12, 15 miles west of Lake Michigan. And I have boiler heat. It's an old home, never had air conditioning. I installed a air source heat pump, and I get to use that thing, and I get heat down to about 8 degrees. After that, it kind of shuts down. But it takes care of all the cooling in my 2-story house. The house is very comfortable all summer long. And in the winter, it provides part of the heat. But I still have a boiler that maintains the rest of it. And then I've got the boilers zoned, basement, first floor, and second floor. Other issue, oh yes, sorry.
I was just going to ask about, you mentioned the fact about resale value being 25% premiums for these homes. Is there some detailed study that has some information around what the market's actually seeing for those homes that haven't certified, what they've turned over and sold for?
Well, if we were to replay my entire presentation, you would probably find that I didn't say that the house itself is 25% worth more money. I did say that. Typically, we find that these homes would be about 25% more energy efficient. And what I meant was that the homes that are certified, we know what those energy bills are, but the fact that they've gone through this certification process is very valuable because they know that a third party looked at it and did the performance testing. That performance testing includes what's known as a blower door test. And that's a large fan that gets inserted in an exterior doorway that blows air out of the house, and you depressurize it to a certain value. And that certain value is the same used throughout the world. It's a metric measurement of pascals of pressure difference. Once we get the fan operating and we get the house at that particular level, we then take a reading on our meter that tells us how many cubic feet of air is flowing through the fan when we depressurize it to that level. The lower the number, the better, because that represents a tighter home. And the idea there is that we actually know what that is. We then take that number and we compare it to the shell size of the building. For example, the shell of this area is the square footage of the floor, all of the walls, and all of the ceilings. We add all of that up, and because every house is different, we then use a multiplier, and we say, okay, for every cubic foot of air that we're flowing through the fan, we don't want it to be more than 0.20 cubic feet when the house is depressurized. So that way we can compare any size home, and it's the same number. So again, the lower the number, the better. Other things that we do on the performance test is we want to measure the ability of all of those exhaust fans, whether it's bath fans, range hoods. We want to know how well they actually work. We want to verify where the fan is being ducted to, hopefully the exterior of the building, not to any building cavity or into the attic or into a soffit. We want it to the exterior of the building. It's really important. Oftentimes, when the manufacturer will manufacture a fan and ship it, they will tape shut the backdraft damper. It's the installer's responsibility to remove that tape so that the damper opens when the fan gets turned on. Well, if the installer doesn't know that, or maybe he's installing a fan that he's not familiar with, forgets to do that. And his test, or her test, is to turn the switch on. And if they hear noise, hey, we're good. We're good. We got noise, we got power. They have no idea how well the fan is actually performing. where we actually use a device to measure how many cubic feet of air. You'd be surprised how many times we find fans that are rated at, say, 80 cubic feet of air per minute, 80 CFM, and they're moving 10 because the backdraft damper was never allowed to open up. So the homeowner wouldn't know the difference. They turn the switch on and they hear that noise. And typically what will happen is if the damper can't open, the motor will ramp up trying to overcome that resistance. The noise becomes even louder. But if it's a brand new fan, the homeowner wouldn't know the difference. So they just assume everything is working just fine. So it's just another great service that our consultants offer, is that we're actually doing that performance testing at the end. Other things that we're looking, I'll get right to it. The other things that we're looking for is we have standards. We have to have insulation on top of the attic access hole. Thank you. We have to have certain kinds of equipment for heating. We don't allow any B-vented chimneys, meaning atmospherically vented chimneys for water heaters, space heaters, or furnaces. If you want to put in a wood-burning fireplace, that's okay in our program, provided that there's outside air for combustion and that the doors are gasketed and sealed. The idea there is we don't want any backdrafting. Whenever you burn wood, every time you burn wood, you create carbon monoxide. And there's the potential to bring that into the living space, because maybe you're operating a clothes dryer or a range hood fan or a bath fan, and you're creating negative pressure with your own equipment. And if you're allowing that smoke and those particulates to enter into your home, that will be carbon monoxide coming into your home. Dave?
If I could just, the guy who asked about cost difference.
Yeah.
One of the things, if you're looking for that, is if you get a builder who does this on a regular basis, once it becomes part of your routine, the cost difference drops way off. For somebody who's new at it, kind of struggling through and learning the ropes, it'll be a little bit extra labor, but once they're used to it, it's just part of how you do things, and it doesn't really cost anything.
Now, Dave's been building homes in this program for how many years?
7, 8 years now.
7 or 8 years? Okay. Dave, do you find value in the program as a builder?
Yeah, it's just what we do now.
That's become your standard
It's
practice.
just our standard practice.
The builder that I was referring to earlier that talked about putting money into the shell, he will not, absolutely will not build a home unless it's certified. He does not want to take that risk. He's turned business down. Can you imagine in this market somebody turning business down because he just has that integrity? But as a result, because he stands by that integrity, he is busy. He's got about 25 projects going on right now, ranging from single-family homes to condominiums. He's doing extremely well selling energy efficiency. Yes, sir.
Do you have a recommendation for surface to volume ratio?
For windows?
No, surface to volume. The surface of the house, all around the skin,
Yeah.
to the volume. Do you have a recommendation of what that percentage should be?
Okay, he asked about, is there a ratio or a percentage of surface area of the house as opposed to volume? And the answer is, I've never thought about that. We don't talk about that particular ratio. We talk more about what is the actual performance number of air leakage as opposed to the measured shell surface of the house.
Do you know if any programs do? Because that's huge. I just don't understand.
Well, you can calculate that and
Passive house.
Well, but if you look at the passive house, do they do that?
Yes,
Yeah.
You want maximum volume per surface area, so you want a cube or a sphere. A sphere is the ideal
Right.
structure,
Okay.
or a cube. Anything you deviate from that, you're reducing the amount of volume or increasing the amount of surface area per volume. So the most efficient structure is a sphere
is a sphere. Okay.
or a cube.
Not very many corners.
Yeah, it's not real common, but the geometry makes sense. Yeah, yeah. Other things that our consultants are testing, for example, one of the requirements or standards is that the sump pump, that lid has to be sealed. We don't allow those to be open to allow moisture and other soil gases, which may include radon and carbon dioxide and nitric oxides and other soil gases to come into the house. Remember that a house in the wintertime is kind of like a chimney. The whole house is warmer on the inside than it is on the outside, and it creates this column of air rising. The taller the house, the more this takes place. In high-rise buildings, that negative pressure on lower levels is phenomenal. Sometimes it's very difficult just to open up a door because of that negative pressure. In a typical residential home, it's usually 1 or 2 stories. We don't see those problems. But the same concept is that air is rising up. So the floor of the attic, which we call the lid, we want that to be specifically sealed as best as possible so that that air rising up doesn't pass through that lid into the space above. Think about a Weber charcoal grill that has vents on the top and vents on the bottom. You're done grilling, or maybe the fire's too hot and you want to slow down the heat, you close the top vents. Think of a house the same way. If you close the bottom vents, now you've choked off the fire completely. And in the house, you close everything off, you've more air sealed the house, it will perform better and be a lot more comfortable, very draft free. Yes, sir.
Do you advocate infrared barriers?
You mean the radiant barriers up in the attic in a northern climate? Absolutely not. There's very, very little value in that.
How about reversing, the reflective part on the inside?
That would be different. That'd be different. I mean, under the insulation? Yeah, that'd be different. What he's asking about is radiant barriers, and they've got people going around doing dinner shows and such, and they're selling this stuff at about $2 a square foot. The value is minimal. Now, in a southern climate, where it's a cooling dominated climate, whole different story. There's value there, but not in our climate. Ladies and gentlemen, I know the next presenter is coming on, so I'm going to wrap things up. I want to thank you very much for your time and attention. Thank you.